Hey everyone, welcome back to the shop and our next machining project. And the project at hand, this is going to be a CNC machining project. It's one that I have already worked on. I've actually already completed it, as you can kind of see some pieces right here. We'll talk about that. But I'm going to approach this video a little bit differently than what we normally do. Typically you see a part on the table here that we have to repair or make, and then we go to the machine and make it. And in this case, you've got some parts here that I've already set up in different stages of completion. We've already got it machined in different stages of completion there. A couple that are finished right here, and the one that is the actual sample is this guy right here. This is what we're copying, what we're having to make. And what this is, it's a brake caliper piston out of a '79 Trans Am. It belongs to one of my viewers named Danny. He lives up in Canada, and the car itself belongs to his son. It's something that he wanted to acquire and work on restoring, fixing it up, those things like that. And so this is a car that he's actually helping his son do. He said that his son always wanted a '77 Trans Am, and he ended up finding this '79 Trans Am instead and bought it. And now they're working on it. It's a great looking car, but with all those old cars, there's always a lot of things underneath the paint that probably need attention, mechanical things and stuff like that. So to give you a quick little backstory on what he's wanting and why he's wanting this right here, this is for the rear brake calipers. He says these are unavailable, but the right side, the rear right side, is available, the brake calipers, that you can still buy those, but he said the left side is unavailable. And the problem that he has with these pistons is that they rust. They're sitting in storage and they rust, and since this is not available part, he wanted to have 2 of these pistons machined out of some 3/16 stainless steel, which is what we have right here. So this is the bar stock that we'll use to machine 2 of these guys for Danny and his son. And I have already gone through all of the work of writing the programs in Fusion 360, testing them, proving them, and actually getting them completed to this stage right here. So this is one that we've already machined. This is made out of 1045 steel. It's actually chrome plated. This is the same material I would have used to make a hydraulic rod or something like that. Some stuff I had around the shop. 2.5 inch OD. That's what the diameter of this piston is. 2.5 inches, and I just use that 2.5 inch chrome bar stock. So you can see I've actually got a good looking part right here, but it took a few pieces to get it to this stage. And I ended up using this job right here as one of my CNC training practice parts for both CAD and CAM. And this has been a great part to learn with. I've jumped on Fusion several times with Kevin over at mechanicaladvantage.com. We've gone through a few training sessions. I believe about 4 or 5 different times we got on there, and he helped me through training me on how to draw this up in Fusion. And then my job was to go to the machines, both the mill and the lathe is what I use for this, to actually machine this part. And these 2 right here, it might be a little bit hard to see. I'm going to get my other camera in here closer as we get into more detail, because I want to explain what we're going to do here. But you may be able to see on the back side, we've got some chatter on this face right here. And on the inside face down in there, we've got some chatter down in there also. So that was some improvements that I wanted to make as I was getting these completed. The other thing that you might notice, we have a couple of grooves here that we have to machine on the OD. And I was getting some chatter in this groove here. This is a full radius groove. And the machine, no matter what I did, just always wanted to leave a little bit of chatter in there. Now, not a big deal. The groove is still functional and on size, but visually it just doesn't look good because you can see the chatter in there. Anybody that prides themselves in their work, you don't want to see chatter in your finished. This one right here represents one where I actually got all of the turn finishes, the face, the bore, the OD, this face back here, looking really good, but I still had a problem with the chatter on that groove there. So Kevin helped me with the different grooving cycles you can use in Fusion. And he said, well, let's use the adaptive grooving. And that's what we did right here. We used the adaptive and it cleared up the chatter. It worked beautifully. So this is the one that represents a good, clean part the way that I wanted it. And now we are ready to move on to our 3/16 stainless steel. All right. So I'm going to get you in here closer. And what I would like to do is talk about each step. So we have 4 setups total that we're going to be doing. 2 for the mill and 2 for the lathe. We're going to start with 1, talk about what we need to do for each step, and then we're going to go to the machine. We're going to machine those steps in there. Then we'll come back, we'll talk about the next one, and so on and so forth, okay? Okay, so our first operation, our first setup is going to be in the CNC mill, and what we're going to do is we're going to go there to put this hole down into the workpiece. I want to get the hole established to a rough diameter and get a flat bottom down in there. Now we'll back up to our sample piece right here that we're copying. You might notice down inside there, you have this notch, and that is an indentation relief for this guy right here. Now I talked to Danny about that because I was thinking this had to be in there, and it doesn't. This really doesn't serve any purpose, I guess, other than giving it more material for whenever they press this shape down into that, whenever they made that at GM. All right, but these notches back here have something to do with the brake adjustment tool that goes on there. It catches this for adjustments. So the inside of that, like I said, that inside right there is not a big deal. So on our parts, this is not going to be in there. But when we do this OD, we will be machining all these features in there. But that'll be later on in the video. So what we're focused on is getting a rough hole established in there. I decided to go the mill route on this instead of just simply the lathe. Reason why is because I don't have any kind of really good insert drills here yet. I'm not set up to do that. The second thing is that the flood coolant system on the lathe, I don't have all the proper hardware I need to be able to allow through tool coolant on the lathe. All I have is the little nozzles that spray the coolant out onto the tool. So I don't have that set up yet. I decided let's just go to the mill and let's just use the mill to rough this out. It shouldn't take very long, and it worked really well. So we're going to be using these 2 tools right here. The first one we're going to use is this high feed mill from Walter. This is one that I got for Walter to do this job. And the other benefit of this is that I can use this on the mill for other jobs. This type of tool you can be removed from this shank and have other tools that go on there. So it's kind of like a universal tool that I can use for other applications as we need. The other great thing about this is that this is part of that M4000 tool line from Walter. It's like a job shop line of tools. You got different face mills. You've seen me use them before. So these inserts right here, I already have several of those, and these can be used on all my other face mills. So it's like an interchangeable, it's a universal tool that works well with my other inserts. By the way, these are the inserts that we're going to be running. You can see it's the SDMT. And those 2 inserts right there already machined all these guys right here, and it did a good job. No signs of wear, visually, no signs of wear, no chipping or burnt up edges, so that has done a really good job. So we're going to use this guy to rough the hole out. Now, because of the angle of this mill right there, it leaves quite a bit of material in the bottom, sort of like a waviness that didn't work well for me. So I decided to adjust that tool path, and once we use the high feed mill, we're going to go in there with this guy. This is a 3/4 inch 4 flute end mill. This is a Titan brand end mill. Bull nose, so it's got a nice 30 thou nose radius on there. And we'll go in there with this just to clean the bottom up flat, and it's going to make it really close to the final depth in there on our face. I left 10 thousandths to be able to face that. The boring bar, once we go to the lathe, we'll talk about that later. It's going to come in there, it's going to face that out, and it's going to look beautiful once that's done. All right, so that's my approach on the operation 1. So we're going to go to our Milltronics CNC mill. I've already got it set up, ready to go. We'll put these tools back in there, and let's go ahead and get our rough bore done. And by the way, once it's rough milled, the bottom is flattened out, we're going to go in there with a spotting drill and then a drill bit to put this hole down through there. And then later on, towards the end of the program, we'll actually be able to open that hole up to the proper size, and we're going to do all these mill features there as well. But for now, we're going to start with this. So let's go to the mill and get started on it. One thing that I did forget to mention is that this piece right here, we're going to go to the manual lathe. I'm going to go ahead and turn this OD to size, which is our 2.5 inches. This is 2 5/8, by the way. I'm going to go ahead and turn this down to our 2.5, and we're going to cut these off in the bandsaw to get started. Whenever I started doing this job, that's how I approached these pieces. I didn't want to have to turn this and part that off. I just wanted to go ahead and start with a piece that was close to size, like this right here. All right, so I'm going to get this manual lathe done first, and then we'll go to the CNC mill. We turn this down to 2.5 inches. Okay, we're at the TRM 3016. Now I went ahead and faced off both sides of our pieces there, broke the edge just to get that part established there. So it's going to rough mill it, it's going to flatten the bottom out, and then we're actually going to deck the top of it off there to bring that to a certain size on our depth. Okay, and then it's going to put the hole in it. So I will mention this, I've already got some parallels in there. We're going to put it in this 3-jaw. This is what we're going to be using to hold it. Now, I will admit, I do not have any soft jaws. I really don't have any soft jaws for any of my vices, my chucks, or the lathe. I know I'm going to have a lot of people that suggest that, and I agree with you. I do need to have some soft jaws. I'm just not there yet. So I either need to see about making some soft jaws for both this and the lathe, or even see if I can find some where they're at least ready to bolt on there. But I just went ahead and moved along on this project, going with what I got. And what we're going to be doing is using this shim stock right there to put around the workpiece, and that'll keep from marring up that OD there. And it worked really well. Once I'm done making the part, I'm actually going to chuck that in the manual lathe and just polish that with a real fine grit emery on the OD, and it'll polish it up and look really good. So anyway, I just wanted to point that out. We got to get our brass in there. This is kind of a two-handed thing, but it worked really well. Let's see if I can get it in there. Open that up a little bit more. And just push it down onto the parallel, like so. All right, and then I'm going to torque this properly, and we'll take our soft blow, tap it down on the parallels a couple times. And then I'm going to go ahead and use our Renishaw, touch off the top just to make sure that I have a G54 Z0 established. So this setup here is going to be G54 work offset. Whenever we come back to it to do the backside, it's going to be G55. But it's basically the same position. It's just the Z height is a little bit different. Let's just make sure we have it torqued good. Tap it down, and that should be good to go. Got our probe ready. We're just going to go ahead and touch that surface there. This will be our Z0 for G54. All right. Easy does it on the Z up. Make sure I don't crash the stylus there. The habit I've tried to get into, and I go ahead and remove it once I'm done and put it away. Before we get started, I noticed my coolant level was getting pretty low, so we're just topping it off right now. Got our trim Microsol 685 going in there, so just want to make sure that's filled up before we start. That also leads me to mention, I had showed this over on Instagram, and I had a few people saying that that's never going to work. You got to have through spindle coolant for that thing to work effectively. And what I want to say is that I've got 4 of our coolant nozzles. I've already got it set. It sprays down inside this bore and it completely washes everything out of there. So just because I don't have through spindle coolant on this machine doesn't mean it ain't going to work good, because it does. So just want to point that out. You'll get to see that. It actually builds up all the chips around this chuck right here by the end of the job. It does work really well. So we're getting pretty close to having that filled up, and we'll go ahead and start on it. This is a messy part of the job. I don't plan on putting the camera in there for this. Just going to go handheld. You guys will watch it as it's happening. Okay, we're ready to roll. Close this up. It's going to get kind of messy here. Bring this guy down kind of slow just to be sure before we start on it. There we go. Not too splashy out here. We're going to be going down to 1.745 on our Z. You can see that coolant, it's washing the chips out of there. Right at our bottom. I got an optional stop going. I had this at 80% just because we were going over to our 316 stainless steel. I'm going to go ahead and bring this back up to 100% for our feed rate. Grab the 3/4 end mill. Now this is going to also do a spiral. I had it a little bit high just to be sure that I didn't crash the bottom. You can see once it gets down to about 1.7, it'll actually start cutting there. So it just adds a few more seconds, but we're only making a couple parts here. And this will clean that bottom up nice and flat so our boring bar isn't crashing into a wavy surface in the bottom of the part once we're in the lathe. There we go. See, now we're cutting. Just using a spiral bore pattern to clean this up, just like our rough and tool path. 745, there we go. Sorry, I missed that last little bit. And we're gonna go ahead and it's gonna go back. It's gonna go back to the high feed mill. I think this is where it's gonna spray. It's gonna deck that top surface off. Take about 15 off of it. All right. And now all we have left is the spot drill and the other drill. I think it's 3/16 drill is what I put in there. It's just a spotting drill. And then it'll grab a 3/16 drill. The hole size was 200 thousandths. So at the end of the program, we'll use a 1/8 end mill to clean the hole up to size. All right, that's it. Program completed. 4 minutes, 43 seconds to get this first operation done. So I think this works pretty good myself. I don't know if you guys are gonna agree. I'm sure there's 99 other ways to easily get this part done, but this is the way that we chose to do it. We got some sharp edges on that face mill, but once we go to the lathe, we're gonna face this again. It'll get all this finished up. This just establishes our proper depth there once we go to the lathe. So I'm gonna go ahead and just clean all this up. We'll put our next workpiece in there. I need to make sure all these chips are out of the way. Ideally, if I had a bunch of these to make, having a set of soft jaws machined to fit these guys exactly, or even have, you know, be able to set a bunch of them in a fixture would be perfect. But we're only making 2. So I don't see the point in trying to go through and try to make soft jaws for a part that I'm just making a couple of, you know. Our shim stock is working good not to mar the surface up. We're ready to hit cycle start and get this one done. All right, let's go on our second part. Got to reduce down to 80% on our feed. Caser just kicked on. Did you guys hear it? First time I ran that Waltzer 1-inch high feed mill down in the part, I was really nervous. Didn't know if it was gonna work, didn't have any confidence in it, but after I watched it cut one, and then cut another one, and cut a third one, I knew it was designed to work just like it was supposed to. And then going in here with our 3/16 stainless made me even more nervous, but it's working really well. This is our sample, our steel piece. There's the one that we just machined right there. Got a nice finish down in that bottom face. Okay, second part completed for its op 1 in the mill. We'll get this cleaned up right here because we're going to be coming back to this for the second op in the mill. So from here, we're going to move down to the ML16 CNC lathe and begin the first op for the lathe work there. Okay, so we have completed the very first mill op there, our first operation out of the 4 total, this part. So we're going to be moving on to the lathe now. And I wanted to talk a little bit about the features inside this and why I think that this is a great job for the CNC lathe. All right, so this is the one that we completed with our practice. You can see the finishes in there turned out beautifully. I was really impressed with the bore and bar and the insert and the finish in which I got down inside this. Also notice we have a couple of bevels out here. We have a bevel here, we have a bevel inside. So some of the features to consider with doing this bore is you have 2 different bore sizes in there, okay? You have this bevel here, you have another bevel there, and it's hard to see it, but there is a radius down in the bottom there. If I grab the original sample, you guys can kind of see. Now, whenever GM manufactured this, they didn't even take it, they didn't take it all the way back to there and clean it up. But there was, I just found a reason just to go there and stop. When you're on this tool path in the lathe, it's gonna take a finish pass and it's gonna come through here and it's gonna clean all of this up in one pass, including this radius and the back face. It's gonna take like another 5 thousandths off to do a back face feature with the bore and bar and retract, and that'll be the finish on the inside. So if you look at these features though, not impossible to do in a manual lathe by any means. But you have a couple bevels there, a couple angles, you know, so you would have to bore it to leave enough material down in there for that radius to clean up and go in there with a separate tool to clean that radius. You have to bore this diameter here, cut the 2 bevels on there. What I would probably do is go ahead and cut this bevel here if I'm doing it manually and go to this point here and stop. And then once I make my finish pass through here, I would have my compound set on this angle and then go ahead and cut that bevel there as well. And of course you can finish that, go in there with a tool for that radius and then face it out. So not impossible to do, but how handy is it to use the tool room lathe, the CNC, and do all of this at one time. It worked out beautifully, and I was really excited about seeing that come to fruition whenever I was testing this piece out. And man, just look at the finish in there. Keep in mind, this is steel, so our finished piece is 3/16 stainless steel. So hopefully we're going to be able to match the look of this here, our sample, match it with our finished part right there. All right, so one more thing to talk about here is on the outside here, you have this outside bevel, and let me just bring the sample up here. If you look closely, you can see there's actually 2 separate angles on there. 2 separate angles. Now, I don't think that that was absolutely necessary. It does make it nice and easy when you have a seal or something going over that. But I wanted to try my best to match this. So we actually set this up. I took some pictures of this when I was setting it up, so we'll show on screen, using my Starrett tools on the Starrett granite plate, the universal bevel protractor, and my height gauge all in combination together. And I set this up in a V-block and actually measured the angle of both angles of these bevels here with the universal bevel protractor, and then went into my Fusion file, and we made those adjustments so that we could come across here and cut both of those angles on there. And on the sample piece, you can see that that's what I did. That worked out beautifully. Really happy with the results of that. So let's go to our Milltronics CNC lathe and see if we can get these 2 guys finished up on our first lathe op. Okay, we're over at the ML16 CNC lathe. Going to show you the tools that we're going to be using. This is our tool number 1. This is a CNMG 431 insert, using a really good Walter insert. It's been doing beautiful for that. We've also got this bore and bar that we're using. This is a 3/4 shank, solid carbide shank bore and bar with a triangular shaped insert. It's doing a beautiful job. Really pleased with this bore and bar. It's nice and rigid and just leaving a great finish on there. Now I've also got these Walter grooving tools in here. These are the MX22 grooving tools. This is a square nose insert. This is a full radius insert. These are going to be used on the second lathe op, so we're not going to quite get to those yet. We'll be on the second op. So, but those are the 4 tools that we're going to be using. I've got the Edge Technology chuck stop parallels mounted in here, and we'll put our workpiece and push it back against those parallels there for both operations. Now, whenever we put the workpiece in here, we are going to have to take our #1 tool and establish our Z. So we'll touch off on the face, and that's how I have our first program established, is our touch off here. It'll go to the correct bore. Once we get that operation done, when we go on to our second op, we're going to be flipping it around, pushing against that face, and whatever this ends up measuring on the thickness there is what I'm going to set our G54Z at, because when we come in to do the back side, whenever we do this back side with our grooves, it's based off this face right here that's going to be finished. So I have to input whatever that length is that we're actually starting with, but we'll get to that on the second op. So let's go ahead and get these guys loaded up and show you what it looks like machining this on the CNC lathe. So like we did on the mill, I got a piece of brass shim stock there just to protect the surface. I've already wiped everything off, so it shouldn't be any chips on the parallels or the chuck jaws here. And once I get it there, I just go ahead and I loosen it back up, push in on it, and then tighten it down. Okay. So whenever I go to touch off my tool for a G54Z, I typically use manual mode. We got this controller here, and I know I haven't really showed this very much. It's perfect for moving it around, so you can see you can do longitudinal with that hand wheel. This is like your cross slide on the lathe. All right, and then to adjust the feed in which it's advancing, you just simply adjust your feed rate right there. So if we bring that down to 5, you can see it looks like it's barely moving. All right, so anyway, just wanted to point that out. This is what we'll use to go ahead and get our tool touched off. And instead of touching it off, what I'll do is actually put this slip of paper in there and just bring it up very, very gently until it gets tight on the paper. And once we do, we'll hit that G54Z, and that'll be our home position for the tools. See if I can get you guys a shot of kind of working the control and bringing it in here. So using my right hand to crank the controller, and once we get it up really, really close, just be careful so you don't smash the insert. I go ahead and bring it down to about 5. Actually, I think I was using 2 on the rapid control there. Just slip the paper in there and just keep bringing it up with the hand wheel. And then once it kind of grabs it where I can't move it, I go just a couple tenths more on that. And you see, in order to get it out, we got to basically tear it. Okay, now I'm going to back it straight back, and then now we're going to go ahead and hit our G54Z. Moved it straight back. Now we come in here on our G54Z, 0 position, enter. All right, Z0. All right, we're ready to go ahead and start cutting op 1. We're going to go handheld with most of this. It does throw a lot of coolant out there, so I think I'll just stand out here with the camera and just try to get the best shot I can of it. So we're ready to close the guard there. I usually just kind of leave this side open there so I can peek around right here. That's generally where I'm at whenever I'm getting some video to show you guys. And let's go ahead and start. I've already got the program ready to go. It's going to clean the face up. Just take 5 thou off the face. Oh, I've got optional stop on here again. This is the scary one. This is the boring bar. Already got coolant on the camera there. Now it's going to start roughing that bore out, getting it close to size. It leaves enough material in there so that when it makes the cleanup pass, it'll clean the radius up. It'll do the bevels, the bores, the radius, and the back face all in one pass when it finishes it. All right, here's our finish. Tries to wad up a little bit there, the chips. Just taking a light cut, 10 thousandths. Now it's on the radius, and now it's cleaning up the back face. That part of it's done. We're gonna do another tool change, and now it's gonna cut those two bevels, the two angles on that outside bevel. Two passes and that's done. There's your op one, finished up. That took 2 minutes and 9 seconds there to get completed. Beautiful job. Let's look at our chips there. So this was during the finish pass. And everything looks good. I'll get the coolant blown out of there and we'll get a better look at that, but it looks beautiful from here. That looks beautiful. Silky smooth on the finger. Yeah, I think that worked out great. Really nice finish back on that face, the bore, the bevel, the outside bevels. Beautiful job. I love it. One more to do. Finished. 1 minute 58 seconds without the optional stop. Okay, we just finished up this op right here in the lathe, our first lathe op. Got that completed. You can see both of our bores look beautiful in there. All right, so we're going to move on to the third operation, which is actually our second lathe op, and that is going to be a representation right here of this guy. Now, this is the one I was talking about before. You can see it's got a little bit of chatter down in that groove. So what we will do is go right back to the 3-jaw chuck, put it against our parallels in there. Going to use my brass shim in there to protect the finish. And what we're going to do is end up facing this to the proper length. So it'll finish it to the length there, and then it's going to turn this OD. And then once it turns the OD there, it'll come in, it'll cut this groove first. That's a square groove. I think you can see that. That one's square, and then this one is radiused. And these are the tools that I was going to show you. These are the inserts. These are my Walter inserts. It's the MX22. They carry these in a wide range of profiles and different widths, different seat sizes. So here's the radius groove that we're going to be, or radius insert that we'll be using to machine. Where'd our piece go? This guy right there. All right, so that's our insert. That'll come in there and cut that. Actually, I apologize. This is the wrong one. This is the 1/8 wide. And what I ended up using to help eliminate that chatter is I have one of these that are 1/16 wide. And Kevin helped me with this. We ended up going with an adaptive grooving toolpath. And what it does, I'm gonna kind of manipulate this. It's gonna come in like this. Just take little passes at it back and forth until it cleans it up. And it worked beautifully. And if I bring up, which one was it that, yeah, this guy right there. You see the finish was greatly improved on this one right there by going to that adaptive toolpath. So once I saw this one done, I knew we had it ready where we needed to go. All right, so a radius tool for that groove there. We have a narrow square nose tool that's going to cut that groove there. And what it'll do is it'll come in and cut it. It's going to plunge it in a few times to get it to the right width, and then do it, you know, like this to kind of cut that bevel in there. And I was just going to show this too. So these are the threading inserts I've been using as well for the MX22. Really nice, strong inserts, and of course you get four tips per insert there to do that. So a really nice, high quality insert. So anyway, that's it right there. Put it in there, face it, turn it, cut the 2 grooves, and then that'll be it for the lathe operation, for the second lathe operation. So let's go back to the ML16 and get the back of these 2 parts finished. I did want to go ahead and measure what our length is here. We can just use our calipers. These are very accurate. And I'm just going to measure this right here. So it looks like 2" 118 and a half. So I'm going to write that down on a note, because this width right here, once we go into the lathe, we need to know what this width is, because when we come in here and find this face and we do a G54Z, we need to input whatever this thickness is, and it knows where this face is, because our finishing on this side is based off this face right here. This is our Z0, so it's measuring out this way. All right, so I just wanted to point that out. All right, we got our workpiece wrapped with our brass shim. I'm just going to go around to all 3, make sure that they're all equally tightened. One thing that I fear of this right here is it actually trying to snatch it out of the chuck. I want to tap it and make sure that it is bumped up against the parallels. Okay, sounds good. Now we got to get our tool touched off on our face. Just eyeball it really close. Bring our rapid down. And come in here with our paper. Starting to touch. All right, now it's got it captured. So that should be good right there. I'm just going to go ahead and just crank it back up off there. All right, before we do anything else, I'm going to Z our tool. All right, let's come in here, and I'm going to go to G54Z. It's asking for the position. This is where I wrote down our thickness. So I wrote down 2" 118, but I'm going to put 2.119 on there, just because, you know, we got a piece of paper that's a few thousandths thick. All right, so 2.119, enter, and there's our Z position right there. So 0 would be all the way up against these parallels right there. All right, So we'll go ahead and get started on that. And what it's going to do, it's going to face it to length. I don't have a bunch of heavy facing passes on there. It's 35 thousandths with a 5 thou feed rate. It'll face it. It's going to turn the OD. Once it does that, it'll come in here to the grooving tools and cut those 2 grooves out. All right, we're ready to go. I'm going to keep my hands on the controls just in case we have any kind of issues. The facing is what makes me the most nervous on this op right here. Not cutting anything at first because I had programmed it to be a little thicker than what we got it. This will be our finished pass on the face. Now it's going to turn the OD. Make a finished pass across there. Finish OD, okay? We're gonna go to our first grooving tool. This is our square nose tool. It's gonna stab it a few times and then it'll make one pass across. You can't really see it, but it comes across and cuts a little chamfer on both sides of the groove. All right, there's our round insert. Now this is where it's doing that adaptive tool path, just going left to right, right to left. Cut the groove. Looks like it's trying to string up a little on us. This should be the finished pass. And there it is. There it is, finished up. I've got some pliers we can use to come in here and get those out of the way. It got stuck on the back side of the insert there. Really nice finish on it. Finish on the face. Feels good. Awesome. Really happy. Okay, one down, one more to finish here. Here's a little better look at it. It's got a little bit of chatter there near the center, which is okay because when we go to the mill, this is all going to be milled out of the middle, so it's going to remove it anyway. Yours look good. I'm happy with it. Just finished up number 2 with the grooves in the face. Looks beautiful. And I don't recall if I mentioned this on the first one there. Cycle time was 2 minutes, 48 seconds. That was optional stop turned off with the second part there. So just under 3 minutes to get the second lathe off finished up. So this is going to complete the lathe work. We're now going to take our parts. We'll go back to the bench and talk about our last operation, which is going to be in the CNC mill. All right, so we just finished our third operation, finishing up the CNC lathe work. I'm happy with the outcome. They look good. So now we're ready to move on to our fourth and final operation. We've completed these three right here. Now we're on to this guy, and that is going to be putting this hole pattern in this face here, as well as this counterbore here. It's got a bevel in there. We've got a hole open up to 200 thou. And then if you notice this notch right here, it's sort of like a D-shaped notch. It's part of that tool that fits in there. So if we're talking about manual machining, this is pretty simple to do with these counterbores. You know, put an end mill in there and you know, bring it up and cut it. This one would be a little bit more tricky to do in a manual mill. You can do it, it just takes a lot more setup. And then cutting this bevel in there would be difficult in a mill too. You can do it, but you'd have to have some kind of angular cutter, or put the cutter on an angle, or go back to the lathe and use the compound. There's a few ways to get that done. My goal was to use my CNC machines to get all of this done quickly and efficiently, and get it done in a beautiful way. So if you look here, here's a look at our finished part, and it worked out great. So for these round features here, which these are sort of like an odd size too. I believe it was around 400 thousandths, something like that. Maybe just under that, 390. Anyway, it's all in the program because I measured all these things and made sure it was all right. But we're going to use a 1/4 inch end mill here to come down, and it's going to do a spiral pattern, just a helical interpolation to cut this to size, those 5. And then it's going to jump to the center and go ahead and machine this counterbore here. And then once it machines the counterbore, it's going to do a spiral tool path to cut this bevel. We are using a bullnose end mill, 1/4 inch end mill with a 15 thousandth corner radius, I believe. And we'll use that to cut that angle in there, all right? Now once it completes that, it's going to change to a 1/8 diameter 4-flute end mill. And it's going to use an adaptive tool path to come in here and cut this D-shaped feature out of there. All right, once it cuts this, it's going to jump to the center. It's going to come in here and just make 1 or 2 passes and clean this up to the 200 thou diameter to match the diameter of the original. That's just a screw or something that goes through there, so it's a clearance hole. So, and that's it. Once it gets that center hole done, this is going to be finished up. All right, so meet you over at the CNC mill and we'll get these guys finished. I'm going to go ahead and install our Renishaw probe and touch off on this surface again, because I just want to make sure that we are working on this exact surface and that I have this right. It should be right, but I'm just double checking myself because it only takes a couple minutes here to do this. Tool 99 M6 run. It's going to put that away and we'll put our Renishaw probe in there. Tool reset, cycle start. Come down nice and gentle with it. Look at that coolant. Okay, we should be close. Let's go to our probe. Single surface Z-axis. We want a G55 work offset. Z position 0. Run. Here we go. Okay, Z position set. I think we're ready to go. I turned off 2 of those coolant nozzles. Now that we're not going to be roughing that out anymore, let's see how that does. It's going to ask to verify that we removed tool 99. It is empty. Tool reset. So this is going to be our 1/4 inch 4 flute end mill. I don't know how the coolant's going to be, so may have to close this. Let's see. All right, I'm going to just stop. I'm going to reset that, fix that before we keep going. I think it's going to work fine there. Let's just go ahead and roll with it. Doing a helical pattern to the depth, and then it makes one, it comes back and then it cleans, makes one pass to clean it up. All right, now we're gonna mill that counter bore in the center. Clean up pass, it's gonna go back in, and now we're gonna cut that bevel. And that's just a spiral pattern starting at the bottom, and it's gonna come all the way up and out with it. There's a look at our graphics. All right, it's going to change tools over to the 1/8 diameter 4 flute end mill. Now, I am going to run coolant on this because we're cutting the stainless. I don't want to risk breaking the tool or anything because of that stainless steel. Using the adaptive tool path. Clean up pass. All right, now it's just going to clean up that center hole to the proper diameter. And that's it. So one last step I think I forgot to mention is we are going to chamfer it. Should be that tool right there, 1/4 inch diameter. I believe I have the coolant turned off for this. Yeah. How sweet is that? There's a 5 thou chamfer to break the edge. That is it. Now that's 5 minutes and 8 seconds. It's actually quicker than that because I slowed it down to adjust the coolant. Yeah, that looks pretty. Great finish on there with that stainless. Okay, part number 2 loaded up, tapped down, it is ready to go. Here's our first one. I'm just real happy with the way that turned out. It looks great. So for the second one, I'll try to get a little bit more detailed video if I can. We'll give it a shot, and let's get this guy finished up. Okay, this was part number 2 finished up. Whenever I was doing this feature back here, I went with just air so you guys could see the tool path. And I stopped the video because I wanted to use coolant to make the finish cut on there. And when I reached up to hit the coolant button, it was out of focus, and it happens really, really fast. So I just wasn't able to get the rest of that. But I think you guys got to see the tool path. Real happy with that, man. It looks great. Let me get that out there and get them cleaned up. We are just about finished up with our brake caliper pistons now. So we're all finished up. We just need to do one little deburr, and that's down inside there. That hole, it's got that sharp edge in there. So we're just going to use this Noga tool right here, just a chamfer tool. You got to be careful with these because the way they got those ground, it'll actually try to pull itself into the material going deeper if you're not careful, especially on soft materials. If I can get in there, and I just want to lightly deburr it. Yeah, that looks good. Do the other one. Just try to keep it straight if you can. Yep. Got that deburred. Only thing left I'm going to do is put it back in the manual lathe right here. We can chuck this area that's turned down, and I got some fine emery cloth that I can use to kind of put an even better finish on that OD. But this is our turn finish, 2.5 OD, and still looks good. I'm not seeing any kind of marks or divots or marring of any type on those OD finishes there. But we will polish it up just a little bit. And the other reason why I want to do that too is because this bevel here, this face, should I say, where the two angles meet the straight face, it actually has like a sharp feel right there, okay? So I would like to touch this with a little bit of Scotch-Brite just to soften that edge and not make it sharp to the feel right there. Just soften that edge up, and we'll polish that OD up, and then that's gonna be it. Those will be finished up after that. That feels better. That looks good. We'll just repeat that with the second one. All right, guys, we have come to the finish line for this project here. And I gotta say, I'm real happy with it. I think this turned out real good. We have good finishes on our 316 stainless parts. I am happy with that. Took a little practice to get here. I think I had mentioned this at the beginning of the video. I wanted to use this as another really good training session for my CNC work, using training with Fusion 360 for the CAD work, and then of course go into the CNC machines to cut these parts out. And I'm just happy with the results there. Another big thanks to Kevin over at Mechanical Advantage for helping me with this. We had like 4 different sessions on working on this piece right here and refining it, and then me coming out to the shop, doing some test runs on the steel and coming back, refining it, making it better, optimizing the tool pass, the feeds and speeds and all that kind of stuff. And you know, once you get through that, then you see you got a successful part. And then when you only got 2 of them to make, in a matter of minutes you have it done. But this was a really fun training exercise is what I was getting at. And I thought it was a really great prime example of how you can utilize your CNC machines to make something that is a little more difficult to do manually. Not that you cannot go to your manual lathe and do this. There's people that do this every day, all day long. Not saying you can't, but I enjoyed using my CNC machines to get this a little bit more complicated out of the normal part done on both the lathe and the mill, with the bevels, the different diameters, the radius in the bottom, the flat nose, you know, and especially these features right here. It just worked out beautifully, and I couldn't be happier. The Milltronics performed great and worked well. So these guys are finished up. I'm gonna go ahead and get these guys packaged up really well and get them sent up there to Danny up in Canada. That's where they reside. I don't remember if I'd mentioned that, but they're in Canada. And I'm really interested to know if these are going to last a really, really long time. You know, 316 has a lot of corrosion resistance to it. And I'm hoping that you know, these are gonna work out. You're gonna have road salt getting on this stuff, which causes this rusting and pitting over the years, all the moisture getting to it. So hopefully this is going to work out for Dan and his son, and they're going to have some brake pistons in their calipers that they'll no longer have to worry about. Even if they have to change out those calipers later on, they can pull this piston out and put it in some new calipers or rebuilt calipers and just keep it going. So I don't know if this is something I don't know if this is something that other people might be interested in. I have no idea if this same exact piston fits, you know, other calipers on other GM vehicles. I don't know, but you know, I've got the programs written for this stuff now, and I could certainly make a few more of them if there was other people out there interested in that. Just have to let me know. But otherwise, I had fun learning how to do it. I had fun sharing the project with you, and the completed job I'm just tickled with, and they look good. So that's going to finish up this video. I hope you guys enjoyed following along. Hope you enjoyed the machining, and I hope to see you back here on the next project. All right, see you guys then.